Then, like the production functions in the short run, in the long run, we are having something called Isoquant. Isoquant shows all the combinations of capital and labor that yield the same output level. Or in simple word, it says an isoquant will show the different combinations of the production factors. When you are having two production factors, an isoquant will show us different combinations of these two factors. In our case, capital and labor. This is called the isoquant curve. If you remember this table, we used this table in the very beginning of this discussion about the production. I highlighted 245, 245, 245, 245. So there we discussed the substitutability. We can substitute something for something else, right, which can be seen at all these places. We are having different values because we have a substitution between capital and labor. Either we can use labor for capital or capital for labor. That is our assumption. So then you can see these numbers, 245, 245. And that tells us the same output level. We will be getting the same output level, but different combinations of labor and capital. If you take here 6 labor and only 1 capital, and here 3 labor and capital, and here 2 labor and 3 capital. Likewise, we have different combinations of capital and labor, different values for capital and labor, but we are having the same output level, 245. It is given with production isoquant, with this one. So this is the production isoquant. We are keeping the output fixed. This curve will be having output equal to 100. So at any place, this will be having 100. But you can have different combinations of capital and labor, K1 and L1. The capital is K1 and labor is L1. On the other hand, here capital is K2 and labor is L2. But we are producing at either point A or B. But if you look at this curve, it says that it is the same output level. Output level is not changing. Output is not changing, only capital amount and labor amount is changing. So an isoquant will show us that behavior, right? It's a curve. So the slope of the isoquant is called marginal rate of technical substitution, or MRTS. We have marginal rate of substitution, which we did not discuss in this class. Marginal rate of substitution means if you want to keep the same utility, you are having two goods or services. If you want to keep the same utility, what you can do, you can give up some of your goods which are available with you. And we can go for something else. Thereby, the amount of the utility that we sacrifice from, let's say, good X, we have good X and Y, we sacrifice the consumption of good X, then our utility will be decreased. To get the same utility, you will have to have some amount of Y. This is known as MRS, marginal rate of substitution, which we did not discuss. But here what we are discussing, a different concept, that is marginal rate of technical substitution. That tells us how we can substitute. How we can substitute labor for capital, at which rate? Capital for labor, at which rate? Which can be taken easily, MPL divided by MPK. Marginal product of labor divided by marginal product of capital will give us the marginal rate of technical substitution. Right? As I told you, it simply says, it shows the rate that one input can be substituted for the other retaining the same output level. So we keep the same output level and replace capital with label or label with capital. So different combinations will be there, and Isoquant will show us the same output level with different combinations of capital and label. And we discuss this. One thing I want to highlight other than that is, if you get into a higher order Isoquant, like here Q100, so Q200, which is above the Q100, which says it's a higher output level. So for simplicity, I have put 200, let's assume. So then at that output level, the combination of capital and labor will not be either A or B. So if you want, you can extend this to produce Q equal to 200. If you keep the capital fixed, you have to have at least L2 amount of, if you keep capital as K1, but labor you increase from L1 to L2 like this, then you can get into a new equilibrium. The same can happen. You keep labor fixed and you increase labor to L2, then you decrease K1 to K2 if you are keeping the same output level. Now, if you keep L2 fixed and increase K to K1 like this, then we are getting into new output level, which is Q equal to 200. Right? Or you can increase both of them. You can increase, let's say you are at L1, you are going to L3, and you are at K1, you are moving to K3. Then you will be having a higher output level. Right? So this tells us, if you want to go for a higher output level, either you can increase capital, keeping labor fixed, or you can increase labor, keeping capital fixed, or you can change labor and capital together. Somehow you can get into a higher output level. If you want to get up to Q300, it is the same. Right? But anyway, remember, whatever it is, higher order of Isoquant will show us a higher output level. Right? So Q300 is bigger than Q200. So Q200 is greater than Q100. Right? So remember that one. This one I discussed previously. Marginal rate of technical substitution equal to MPL divided by MPK. Marginal product of labor divided by marginal product of capital. And if you look at here, you see, so you have this much of capital and this much of labor. And then you decrease this much of capital, you got this much of labor. And then you decrease this much of capital and this much of labor. Likewise, you can further. Right? The amount of that you are sacrificing from L will be decreasing. So therefore, we say marginal rate of technical substitution is decreasing or diminishing as more of one input is mixed with less of the other. Right? So if you are going for more and more of one production factor giving out from the other factor, the amount of the other factor that we are sacrificing will be increasing. This is because simply, you see, in the beginning we can mix, right? So you can give up certain amount of the factor, but with the little amount of the other factor, you can retain the same output level. But when you are increasing the second factor, with more and more amount, then we will have to give up more from the other. Therefore, we are having this diminishing relationship, right? Or you can simply look at this graph and say we are having negative slope. Right? All these are having negative slopes, therefore it is getting decreased.